Have you ever driven past an empty field and spotted a massive metal creature slowly bowing its head to the earth? Some call them rocking horses or thirsty birds. In the oil industry, they are known as pumpjacks. These silent giants look simple, almost hypnotic, but beneath the dirt, they perform a brilliant feat of engineering stretching thousands of feet underground. Perfected in the 1920s by an engineer named Walter C. Trout, this device revolutionized the modern world by rescuing trapped oil that could not reach the surface on its own. Welcome to Simple Things Surprising Histories. Today, we are decoding the nodding donkey to find out, how do oil pump jacks actually work? To understand the pump jack, think of it as a giant motorized seesaw. At the back is the prime mover, usually a sturdy electric motor. This motor spins massive steel blocks known as counterweights. These spinning heavy weights aren't just for show, they perfectly balance the immense weight of the oil and the miles of underground steel rods being lifted. This clever use of gravity means the motor uses surprisingly little energy to keep the massive machine moving. As the counterweights spin, they push a lever connected to a long, horizontal walking beam, and at the very front of this beam is the curved metal piece that gives the machine its animal-like appearance, the horsehead. As the horsehead nods up and down, it pulls a steel cable attached to a perfectly smooth metal bar called the polished rod. This rod disappears straight into the ground through a tight, leak-proof seal. But the rod doesn't stop just below the dirt. It connects to a continuous string of steel poles called sucker rods that plunge vertically into the earth. This metal spine can reach over a mile down into the bedrock, right into the dark oil reservoir. But simply plunging a rod up and down doesn't bring liquid to the surface, so how does the oil actually climb that massive distance? The real magic of the nodding donkey happens in total darkness at the very bottom of the well. Attached to the end of the sucker rod is a specialized pump barrel. Inside are two brilliant one-way mechanisms, the traveling valve and the standing valve. They act like tiny trapdoors that only open in one direction. When the pump jack's head dips down, the rod pushes down into the fluid. The bottom standing valve closes tight, while the upper traveling valve pops open. This allows the pump to slide downward through the trapped oil. Then comes the upstroke. As the pump jack's head rises, the traveling valve snaps shut, catching the oil above it and lifting it higher up the pipe. Meanwhile, the suction from this upward pull forces the bottom standing valve to open, drawing a fresh batch of oil from the earth into the chamber. Stroke by stroke, the valves alternate. The oil is forced higher and higher until it finally spills out at the surface. When an oil well is freshly drilled, natural underground pressure usually forces crude oil to the top, but eventually that pressure drops. Without what engineers call artificial lift, the well would be completely useless. That's where Walter C. Trout's 1920s invention comes in. The modern pump jack is so perfectly engineered that its core design has barely changed in a century. It operates day and night in the harshest climates, relying on rugged mechanical physics to extract the resources that power our world. So, the next time you see a nodding donkey silently bowing in a distant field, you'll know exactly what it's doing, reaching deep into the earth to drink from a hidden reservoir. Thank you for watching Simple Things Surprising Histories. If you enjoyed this journey underground, please hit the like button, share this video, and subscribe for more fascinating stories hidden inside the everyday world. See you next time.